In IQ Lake below one folder, there are IQ samples from the 5G base station, the Ericsson base stations. The IQ sample is saved in this folder. If you open the post-processing code, the code is designed by the 5G toolbox. And check the folder names, and if you run the code, you can see this error message if you have the 5G toolbox. Go inside these lines, and you need to add folder of the 5G toolbox and go back to the source code, post-processing code, and you can run it again. The first step is generating spectrogram. The spectrum and time domain IQ samples. You can see the signal. This is SSB of the NR's signals. And you can see the figures from the synchronization by the PSS sequence signal, and this correlation peak shows the NI2 detection and frequency offset detections. In this case, NI2 is 1. And then we find NID1 using the SSS sequence. In this case, NID1 is 0 is detected, so cell ID is 1. After that, you can see the SSB index detections. SS index is 0 in this IQ samples. And you can see the resource grid that as this is grid of the SSB, and this is channel estimation result for SSB. And you can plot the RSRP and RSRQ from the multiple IQ samples. To run that, you can configure figure visualization off for all other figures and clear the breakpoints. And you can run the whole code. You can see that code is running and processing the IQ sample inside of the IQ folder. It takes quite a long time, depends on the number of IQ samples in the folder. After the processing is end, it generates RSRP and RSRQ plots. Depends on the time of the experiment. We collect IQ samples from the regular 1 and regular 3 with RF front end and without RF front end setup. The April 24 data is with RF front end and April 23 data is without RF front end. And we compare 4 different cases in the spectrogram and synchronization and RSRP. And this is the map of the alpha experiment site. There is a regular 1 and regular 3 locations. And X base station is really close to the regular 1. First, we check the first case is regular 1 with RF front end. And control panel change the plotting figures and run the code. We plot the spectrogram of the IQ samples. We can clearly see the LXM5G signals. And in cell search, we can see the correlation peak from the PSS and SSS. Then go to the regular 1 setup without the RF front end. Without the RF front end, the signal strength is really low. You can check it from the spectrogram and correlation peak, but still the cell search is correctly operated. So cell ID is detected correctly. Then go to the regular 3 cases with the RF front end. Regular 3 is far from the Ericsson base station compared with regular 1. Because of that, this signal strength is lower than regular 1. You can see that in spectrogram. But still, cell search is success. Find the correct cell ID. Then we go to the regular 3 without the RF front end. In this case, we cannot find signal 5G signal because signal strength is really low and we don't have RF front end. Because signal strength is too low, cell search is not properly operated, wrong cell ID is detected, and correlation peak is not clear. Now we decode whole IQ sample and plot the RSRP. The first case is regular 1 with RF front end. Run the code. Decode whole IQ samples from the Ericsson base station. And you can see the RSRP and RSRQ result. We will compare RSRP for 3 different cases: regular 1 with and without RF front end, and regular 3 with RF front end. This case is regular 1 RF front end. And we simulate again without RF front end. This is RSRP and RSRQ result from the regular one without RF front end. And this is regular 3 with RF front end. RSCP and RSRQ results. And we can compare RSRP, which is received signal strength, for 3 different cases: regular 1 without RF front end, regular 3 with RF front end. You can clearly see the signal strength with and without RF front end, and it depends on the location of the fixed node.